Okay, good morning everyone. Welcome to another sessions of our AI class. And today I'm very excited and happy that we finally going to be doing some machine learning, which is the what we actually, you actually register to do this. Like you're not learning Python is just a tool, but the class of this class is actually machine learning and AI. So let's do that, shall we? Okay, so I'm going to open the lecture called the first lecture in the folder called classification. So I guess the first journey that you should do in your machine learning or AI class is to do classification, meaning that you are going to predict if your input has a certain class, usually a string, or it can be a number. But you're not predicting the number yet, you're predicting the class like cats and dogs. It's called classification. And the simplest one is called binary classification, which you only have two classes, either 0 and 1 or true and false or something like that, shall we? And the kind of like the basic model that we're going to use today is called Perceptron. Think about Perceptron as a linear model. Like when you do like when you talk about function, usually the first function that you learn is linear function. Same thing with the classification. We're going to use linear function. It's called Perceptron model. Okay. And this one you can just skip it because we already installed everything we need. Okay. And the step it's generally going to be the same no matter what model you're using. And later on, you're going to use a lot of complex model. What we're going to do the same thing, which is load the data, right, that we need, explore the data a little bit. It's good for the data scientist to understand what your data is about, how many columns, if there are any missing information, we should take care of that before we go on. And then we're going to prepare some data for the machine learning to be in the correct format. And then we split the data, and then we'll talk about this. This is called the train and test data. And then we're going to do some feature scaling, meaning that the number needs to be toned down into a certain range so that the model can optimize that the learning in that range. And then we're going to choose the model and what is called the hyperparameter. So that's kind of like the big thing in the machine learning. If you are going to do this for real, choosing the right parameter for the model can be, your own research, for example. Like that would be the most difficult part. Okay, and then once you have everything, we're going to train the model, and then we can evaluate the model, and then we can make some prediction. Okay, so hopefully we can finish all of this today. So first, we're going to load the data, and I guess the toy data that everyone's going to have to go through in your machine learning journey is called iris dataset. Okay, so that's kind of like the most popular data sets for the machine learning, right? And in this data, it's a data of the flower, as you can see on your right, on the right panel. And these are the classes. Okay, so iris setosa, versicolor, and virginica. So that's the name of the flower, I guess in an official name or something. And in order to predict the class of flower, as I can show on the right, it looks pretty much the same, right? So how do we distinguish between each class? So in order to do that, you're going to have to come up with the input that we call attributes. So in order to separate between each class, we're going to have to measure something that actually differ between among the classes. And this one is determined to be the length of the sepal. It's called sepal length, sepal width, petal length, and petal width. I think in Thai, because I always confuse this one, sepal is กลีบเลี้ยง petal กลีบดอก in Thai. Sorry guys, I don't know. This is what it is from biology class, right? You probably know it, or I don't know biology, so whatever. Okay, so here we need to determine beforehand what we are going to use for the attributes, and I guess we are using 4 attributes, and hopefully that will work. If it doesn't work, you have to find more. You have to find the attribute that actually that can distinguish the class. And that is something you have to know from your domain of knowledge. For example, you have to get a biologist and say, how do I distinguish between the class of this flower? And you got to have some knowledge into to pick this, the choice of this attribute have to come from the domain knowledge. Okay, and once we get the data, somebody has to actually go and measure it. So for each of the flowers that we know the answer, we have to measure the 4 attributes. Okay, and once we do that, we are going to put them into the table format, and that is when Panda comes in. Anything tabular that you think can be put into Excel, think about Panda. Okay, so this is going to be the one. So, right? For example, the column 0, 1, 2, 3, which is the first to the 4th column, is going to be the attribute, the 4 attributes that we mentioned, and then the last column is going to be the class. Okay, right? And in order to do that, we are going to kind of talk about the notation a little bit, because whenever you see something that as a column, think about it as vector. Like vector is a series of number in mathematics, right? So we can also think about, for example, I should use the red pen. Oh, sorry. Okay. For example, like just ignore this one. This one is just index, right? Doesn't really matter here. But the one that we want is actually, for example, the first one. The first column is just a set of number, and that column is actually the sepal length from different flowers, right? Different sample of flowers. And this one, if it's a set of number, then we can call it vector. I'm going to call it vector x1, right? And then if the second column, it's actually the sepal width from all the flower samples, I'm going to call it x2. So think about vector as the column directions, something like that, right? So we have x1, x2, x3, and x4, although the number is kind of switch off is a little different due to the index that start from 0. But anyway, so these are the x, and also this is a y. Okay, so I guess we can think about it as we have 4 vector, and then it's going to go into some model, and it's going to output the vector y for you. That's the answer. So that's what the model is going to do. Okay, and the way that we usually write the notation is that we don't really know how many this is. This can change. We can have 4, or you can have 1,000 attributes, up to you. It depends on the domain knowledge. Okay, so we're going to group everything together and just write the X right here. So when you see the big X like that with the kind of the bold-face font, it's going to be, you can think about it as a matrix. Consists of a lot of attributes, vectors. Okay, but then it doesn't matter how many vectors in our X. It can be as large as you want. The output is going to be the same thing, which is Y. So that's a problem statement here. So given X, give me Y. That's all. That's how the model is doing. Okay. Okay. So let's look at the data in our Python code, shall we? Okay. Let me. I need to set this one up too. I forgot to load my my notebook in here, so 1 second. Okay. Okay. So you can follow me, follow the code that I do, but I'm going to type it separately because I think that's more, I can explain them just step by step, okay? So first thing is I'm going to load, actually before I even load anything, so this code is something that I use because I don't want to reuse the code that's used for plotting. So this one, it looks a bit complicated, but what it's doing is that it's telling the system that there is another folder called the util, and that one, please search for it in terms of the wait, sorry, I don't need this one. I need this one, okay. Okay, it works, okay. So this box just tells that there is a folder called S00 util, And if I'm going to call a function, then make sure that the system actually know that there are some files in here. And the file is called util.py. And these are the files that I use for plotting. So it's long, but I don't want to reuse this file in all of the folders that I have subsequently. So that's why I'm declaring right here. So this one just for me, so that I can reuse the code in my util folder. That's all, okay? You can ignore this for now, but you gotta run this one once, or else the code down below will not work, because I use the code from my utility folder, okay? Wait. And the next thing is I'm gonna load the library. So this one is a bit overkill, but let's do that right now. Okay, just load everything, okay? And as you can see that I'm loading NumPy, Panda, and now the new one, sklearn. So that's the library for machine learning. Take some time. Okay, I finished loading, and just to remind you one more time, the fact that this line works, like from util import plot.ds, this line works because I run this the code blocks up here. So if you just copy my code, this code will not run on its own, because it's going to say that I don't know where plot.ds is. And the reason that this one works is that I have declared here that if you want to find util, go look into this file. So that's what the first block does. So when you copy my code, make sure you copy, I guess you have to copy the whole thing, including the folder structure. So it's kind of complicated, I know, but this one makes me so that I don't have to rewrite the code in every file. So bear with me for a bit. Yeah. Okay. And the next thing is I'm actually going to load the data, okay? So the way that we load the data, there's many ways that you can get the data, right? Usually you get it from the Excel or CSV, but then scikit-learn already give you some of the data that we use a lot, and iris datasets is actually one of them. So that's why I'm loading right here. From scikit-learn, import dataset. So this dataset is actually a function that you can use to load the data, right? So this one is specifically for this dataset. If you have other dataset, it might come from different source. So that's something that you gotta have to look into it separately, okay? But this one, we can do something like this. Dataset.load, okay? And I think, load iris, okay? Okay. Oh, dataset with S too, sorry, okay? So if I were to run this, see there's something coming out. Right? So that means that it's working. And again, if you're wondering like how do I know about all of this syntax, everything's in here. It's in the documentation. So let me just show you that there's nothing that you cannot look up. You can do dataset when I go to scikit-learn, dataset, right? You can search for it, and these are the page that specify how you load the dataset. For example. So it's saying this one is too old, so switch to the right here. So the one that I want is right here. So datasets.load iris, and I can click into it, and I can see that what it's doing. So I can say load iris, and it doesn't return, it doesn't need anything, and it's going to return me 3 things, which are exactly what I got from here. Okay. So what I want is actually I want to keep the thing that is returning from this this function into something called data object, okay, like that. So right now, I'm keeping all the input, the output from this function, and then split it back into this object. And if I want to look into this object, I can have something called dir data object. So that's a quick way to look inside what there are. And there are a couple of things that I can use. Well, actually, a lot of things. The first thing that I can use is actually this guy right here, describe. This thing is a description of the data. So I can do something like this, print, okay, data object dot, actually DESCR. So if I were to do that, I can get the description of the data set. So maybe I might go a little bit too fast. So let me just show you what the data object is, okay? I can go to terminal and Jupyter. And as you can see that the data object is kind of like a class instance, right? It's a special class instance from scikit-learn, And the way that you do is that you can access its attributes, which are all of this guy right here. Okay, so you just do dot and that. So that is a class instance. Okay. So if you print this thing, then you can see that these are the data set. There are 150 sample and 4 attributes, which are this. We talked about it already. And then just a bunch of more information. So that one's okay, but we don't need that one per se. What we need is actually this guy right here, data object dot feature names. Okay, do we need this one? We kind of need it in a way. So that one is called, it's the name of the attribute in each of the columns, right? We talked about sepal length, sepal width, petal length, petal width, right? So that's a feature name or attribute names. Another thing we might want is data object dot feature class name, target name, okay, target name, okay? So this one tells you that if you're machine learning, the way that they encode the data is that this is the order of the class. For example, in the machine learning, sorry?
Can you scroll through all the codes again?
Okay. Sorry, so, just remind you that the code's actually in here. All right, you can kind of click into here. Okay, it's already in the C1/binary. I'm just retyping for you from scratch so that it's, for me, I guess it's better for me to explain. But you can just simply just hit enter to see what happened, okay? But this one just telling you that these are the objects that get returned from the loading function. So this is only specific to the machine, to the scikit-learn library. So this is not universal in any shape or form, okay? Right? And this one just tells me that if I were to get the numeric representation of the class, these are the definition. So if I get 0, that means it's setosa flower type. And if I get 1, it's versicolor type. And if I get 2, it's virginica. Okay. Again, this one is not the real data yet, right? The real data is actually this one. It's data object dot data. So this is the real data. As you can imagine, these are the 2-dimensional array, consists of 4 columns. And we just talked about it, right? The attribute, we have 4 attributes, right? And each attribute, you can think about it as a vector. So we have 4 vectors, x1, x2, x3, and x4. So that is the input of your model, per se. Okay? And as you can see that this one is actually a NumPy array. So inside, under the hood, they're using NumPy library to represent the numeric data. Another thing that we might need, we need for sure, is actually data object dot target, okay? See? And this is the y vector, right? Remember, if I go back to our notation, these are the x, right? I mean, I should write in here. So this is x, x1, x2, x3, x4, and these are y, right? So you need 5 columns in this data structure, and these 5 columns are the first 4 are in object.data, and the last column is in data.target. Although you can see that the representation are a bit different because in the x, this is the big X. So the big X is like a matrix. So it's representing as a column and row. But when you talk about y is just a vector. So it's, when it's a vector, it's just 1-dimensional array. So that's why it's represented as in a horizontal way like this. But this is another column, the y column. It just gets represented in a 1-dimensional manner. Okay? So if you want this to look similar to what I show in here, right? I mean, this one makes more sense, right? So let's put them into data frame. That's my favorite part about Panda. Like you get your data together and it looks like Excel. So let's do just that. Okay, we're gonna do pd.dataframe. So that's how you create a data frame or Excel spreadsheet. And you want to input the data. So the data is called data object.data. Let me just show you what happens if I just do something short like this, okay? actually you already get your data right away. Like in my code, it's a bit longer, but I want to show you the shorter version. So this one contains all the X, right? But then notice that the index is still not meaningful. Like for example, the header is just 1, 0, 0, 1, 2, 3. It should be something that we know, which is the name of the attributes, right? And I guess this one's okay, the row, because this is I guess the number of samples, but that's fine. So I want to fix the header a little bit so that it's more meaningful. That's why I say column. That's another argument, equal. And we already have the name of the columns. It's written in data object dot feature names. So that will give me the list of the feature name. Wait, feature name without S, I guess, like that. Okay. So if I were to do that, it looks much better, right? Now I have the header that has a meaningful name. So that's the nice things about Panda. It gives you this ability to make your data looks better. Okay. So I think that's it for the X. But I think we want Y too, right? We are missing one column, which is the target, or I guess the prediction, right? Not prediction, but the class column. So let's do just that. I'm going to put this into df. So I'm going to keep this variable into, I guess, keep that data frame into a variable called df. And then just like that. So it doesn't print out anything, but it's there already. But then I'm going to create a new column called target. So I can do something like this. Target, okay, equal. And then data object dot target. So that if I were to do this, I'm saying that create a new column called target, and that data is going to be equal to the data object dot target. So that is the one-dimensional data that we just looked up previously. Okay. So if I were to do this, I can do df dot head, which is give me the first five rows in the data frame, like that. Okay, it works. So this one looks much better, right? Because all the columns, all the header rows are meaningful. And we can also inspect it in the way that, like I usually do in Panda data frame. For example, I can do something like df.info to check a couple things. This one, I guess, is a little bit extra. But I can see that there are 5 columns and 150 non-null, which is good because that means that I don't have missing data. Okay, so that's a good one. And I can even do something like, I guess I'll show you later, okay, later. But so that's the first step, like kind of like aggregate everything into the data frame. I guess that's the first step that you want to do. Okay, so for you, if you want, just probably click until explore data. Okay, so that's the step that we did. Okay, so the next one is the data exploration. So for me, as a data, I guess when we work with data, it's good to explore the data a little bit to see if our choice of attributes kind of makes sense or not. Okay, and if there's anything that we need to clean the data before we go on. Okay, and for here we can, I think Panda is perfect for this job. Okay. So first, I want to check, maybe if I want to check the missing value, I think this info is pretty good. So I kind of identify that there's no missing value. So everything's good, right? And then I can even do some like statistics for it, right? I can do df.describe. So at this one, I didn't type it in here, I think, but we can do this. So this one gives you the statistic for each column if you're curious. But this one actually throws you a lot of number, and sometimes that doesn't, like, that you don't kind of get the feeling, like you don't feel like you know the data that well. So plotting is probably a better idea, and Panda is perfect for plotting that data. Okay, so we're not going to use this one, but the one that I really like is something like this, df.hist. So this one is a histogram, and you're going to see that it's pretty cool, like that. Okay. Look how fast it is, right? You just plot 5 histograms with just 1 line of code. That's so short, right? So this one is a bit too small, so I'm gonna input some argument to make it a little bit bigger. So I'm gonna do fixed size. So that's telling you the figure size. it's going to be equal to the tuple of two value, which is the width and the height, I think. So 10, 10. So that gives me, I guess, bigger windows to look at, right? And what you're looking at is a histogram of your columns, of each column. As you can see, sepal length, sepal width, petal length, petal width, and also the target. So the first thing that you should do is see if it makes sense, right? I mean, and to say that it makes sense, you probably need some domain knowledge. For example, if you know that the sepal length should be, somewhere between, 3 to 6 centimeter, I think that one's good, right? But then if something shoots off to be like 100 centimeter, then you know right away that there's something wrong. And this histogram is pretty good for detecting something like that, right? Again, another thing that you can do is that it actually, like if you see something like this, for example, you see the two groups, right? Then you kind of know that maybe this is a good attribute because you're trying to separate between different classes. And if the data kind of separate into groups, then it has a high chance of being actually useful in distinguish the class in the model. Like sometimes if you can come up with the attribute that doesn't really contribute to the accuracy of the model, and that's noise. So it's good to check your data to see if something might be useful. For example, I think petal length is pretty useful, okay? And also it's good to check the target too, because this one shows you that you have class 0, 50. You have 50 flower that you collect from your observation, and the class 1 and the class 2. So you have a balanced sample. And that is actually a big thing, because when you go into your real data collection, you're going to find that it might be very hard to collect a certain class. For example, if you are detecting disease and that disease is rare, then you are going to end up with an imbalanced data, meaning that one class you have so many patients that it's okay, but you have very small patient sample that has disease, and we deal with that later on, and that's actually quite a big topic on that. It's called imbalanced learning. Okay, but that means that our data looks good. We can move on. Histogram is one thing I like. Another thing that I like is a box plot. Okay, so let's check this one out. It's called box plot. Okay, see, and if I were just to do this, right, nothing like no special, no further arguments, I actually can plot it, like, but it looks a little bit cluttered, so that's why I have more options to make it look nicer. Okay, so the first thing is that when I look at the box plot tells you a couple of things. First, the average or the average of your, I think it's the median, which is a 50 percentile, is in the green line for each of the columns. And then I think the top and the bottom of the box is the, I think it's like 75 and 25 percentile. And the width of the whisker, it's the like IPR, inter percentile range, something like that. You can go look what it is. But this essentially tells you your data distribution. And of course, the circle is the outlier. So the box plot is going to tell you that, for example, if you see outlier, make sure that your data is okay. Like make sure that if there's a lot of outlier, maybe you should go back and look into your data to see what if there's something wrong, right? So I think box plot and histogram is a good way to kind of grasp the overall shape of your data distribution. Okay, but here's the thing: when you do box plot, I don't really need this one, right? Because this one is my y. Like I don't really need to know the distribution of my y because it's kind of meaningless, right? It's just zero. It's 0, 1, and 2. So I'm going to get rid of the last one. So that's why my code is a bit longer. So in order to do that, I'm going to say that I don't need to plot everything. I'm going to need only 4 columns. The first 4 columns, that's why I do I-log. Okay, if you recall from last time, I know it's kind of, I went a little bit fast, but I-log is a way to select the data frame numerically with a numeric index. For example, I want to select all the rows, but I only need the first 4 columns, so I'm going to go from the first column to the 4th column. That's how it works. Okay. So 0, colon 4, it's first column to the 4th column. Or you can think about it as the the first column to the fifth column, but back one step to become the fourth column, like the way that we do with the string selection too. Okay, so if I were to do that, see, I can get rid of the first, the last column, which is it's not that meaningful. And again, I think this one is a bit too small, so I'm gonna make the size bigger. So fixed size equal. What do I have here? I have 10 and 8, so it's wider, right? A little bit shorter, I guess. Okay, something like that. So this one looks better in terms of the size and everything, right? So yeah. And feel free to save it if you want by using this save but icon. It's pretty convenient. But again, if you want to save it with the code, that's also possible too. Okay, so we'll go into data exploratory more in the next example, but I want to skip that. I want to move on to, let's say that our data makes sense, which it does because this is the most famous data in machine learning, so it should be okay. So the next step is we're going to prepare the data. So this one, we are going to make it even simpler because we're not going to use 4 attributes. We're going to use only 2 attributes to select the class. And the reason I do that is that if you only have 2 attributes, you can visualize what the model is doing in the 2-dimensional plots. That one is, I think, it's more, it's good for learning the model behavior. But later on, you can increase the number of attributes later. Okay, so we are going to eliminate one, and then even better, we're gonna eliminate one class of flower too, because right now we have 3 classes. 3 classes is not binary classification, so we need only 2 remaining. Okay, so to make it to be binary classification. Okay, so sounds a bit complicated, right? You gotta have to do multiple things, but in Panda, I wouldn't say it's easy, but it's short. Okay. So in order to do that, I'm gonna do this df, right? I'm going to choose just the subset of the column. So let's do this. I'm gonna do what I log, right? So I'm going to choose all the row, right? But then for the columns, I want to choose the 3rd, the 4th columns, and also the y. So if I were to do this, I get everything, right? But I think I want the petal length, petal width, and target. I only want the last 3. Okay, so that's why I'm going to do, there are multiple ways to do. The way that I do in my code is just specifying the index, which is 2, 3, and 4. 2, 3, 4 mean the 3rd, the 4th, and the 5th column, right? If I were to do this, I get the last 3. So that's one way. But if you want to do, but there are other ways you can do. For example, I can do maybe, I want the 3rd column, and so on. No, that one without the bracket. So that one works the same way. Actually, no, actually 2. Same way. Okay, you can do that too. Or you can be more specific, like df.ilog, but then I can do 2 to 5. So that one also works too. Okay, so that's the thing about Panda, because there's so many ways to do. It's kind of confusing for the newcomer, but it's kind of convenient if you start to get a hang of it. Okay, and again, if I were to do df.ilog, I haven't done anything to the variable, right? So I need to save this result somewhere else. So I'm going to say df2 equal to save the data. Okay, and just to show you that it works, I'm going to do df2.head. Like that. So just to verify that I already have the last 3 columns, including the target. Okay. All right. So we are set with the first bullet. We only choose the petal length and petal width, right? The next task we're going to do is we're going to eliminate one class of flowers. So if I were to I want to see the count of all the classes I have right now. What I can do is I can do this df2, right? And if you just want to select one column, you can do something like this, target. Okay. So that is a quick way of selecting just one column. You can do this, target, okay? And if you do this, you only get the Y columns, right? Even though, but again, even though it's just the Y column, it has to have the row index. So this is something that that's kind of nice about Panda. It's like if it's just one column, you still get the index so that you know where it comes from, okay? But essentially, I want to see how many classes I have in my Y. So the way that I can do value count. So that's a very useful function. This one's going to tell me how many zeros and ones and two, and it's the class, I guess the numeric encoding of the class, right? I have 50 each, so I want to eliminate one of them. Let's eliminate number 2. So I want to get rid of class 2 away, okay? And the way I do that is similar to how you select the movie last time.
Did you define DF2 before?
Yeah, I did. So if you go back to your code, it should be right here, DF2, right here, okay? So normally I don't overwrite things because if you overwrite things and you rerun this statement, it's going to give you error. So I always rename into a new variable so that you can keep running this and then it doesn't give you weird errors. So that's my trick. It's called the star is called immutability. Like you try to, you do not want to modify the existing variable but assign to the new variable. Okay, in order to get rid of number 2, it's the same thing as selecting the movie last week. So I'm going to come up with the filter. So my filter is going to be df2 target, right? It has to be equal to 1, 0, right? Or it has to be equal to 1. Or I mean, you can also come up with the name, the condition that it doesn't have to be equal to 2, that's fine. But I want to show you the longer version. So I have to put parentheses. This one gave me error last time, so now I remember. Okay. So this is the filter that's telling that we will use to select just the target number that's equal to zeros and 1. Okay. If I were to type fill right now, you can see that this one is called the Boolean. It's just a Boolean value, right? But then it's going to be true at the location where the target, at the row index of y equal to 0 and 1. And it's going to be false otherwise. So this one, we can put this one back into our data frame, like the movie last time, in order to filter out. So I guess I use df2, right? And then I put in the filter, like that. See? And then I put in like that. As you can see that now I have only 100 rows. Which makes sense, right? And then I want to save this result in another variable called df3. Okay, so I don't modify the existing data. All right, I create a new one. So df3, right? So that's why if I do df3, I guess I do dot target, right? I want to check again if it works. So dot value counts. Then I only get zeros and 1. So it's a way that you filter the data. Okay, I wouldn't say it's easy, but after a while you appreciate the conciseness of it, and then you can rerun this thing all the time, anytime you want, which is pretty nice. Okay. All right. And here's the thing, once you only have 2 attributes, you can also plot things in a more, more revealing way. So let's do just that. So if I were to do df3, right, dot hits, so histogram again, as you can see that I only have 2 attributes, right, and then I have the target, which are zeros and 1. So that's good, right? I even say fixed size is equal to 10 and 8, so width of 10. The unit is inches, okay? Okay, and if you only have 2 attributes, actually what you can do is you can do scatter plot, because you can make x to be, the horizontal axis to be one attribute, vertical axis to be the other attribute, and then the dots or the location of your data is actually specified by your target, like the location type specified by your target, okay? So let's do just that. It's called scatter plot. Okay, so we'll do df3 dot plot dot scatter. Okay, so all of this, it's in Panda documentation. I just look it up, right? So I want to do x equal. You need to type the name of the header. So it's going to be, I don't have it anymore, but if I were to do df3 dot columns, that's what I need. That's the name that I need. For example, petal length in centimeter. So that is the, not this one. I need the guy right here. Yeah, okay. And then my y would be equal to the petal width, like that. Okay, like that. And there you go, okay? So if you do scatter plot, then you can kind of see that, yeah, the data is actually separate into two groups. I mean, I don't have the color here, but take my word for it, okay? One of the class is actually in here, and the other class is in here. And I mean, and you're going to see that actually machine learning model is nothing special. It just draw a line. And the first way, the first model that we're using, which is a linear model, it's going to draw the straight line that's separate between these two classes. That's how it's doing. I mean, you can even do it from your eyes, right? You can just do that one, right? And that would be something that you would expect. And that's exactly what the model is doing. So once you start to see the pattern or you see this behavior, you're gonna see that there's nothing special about AI. AI is just mathematical function that do something that we can do by ourselves if we can see the data like this. Okay, and and the last thing that I'm going to do is I'm going to actually extract everything back into NumPy array. And I guess there's no special reason to that because I'm just following the documentation and they did this because I guess NumPy is slightly faster than Panda, so maybe that's the reason. But you don't have to do this step. You can just keep your Panda and work with the Panda library throughout your process. Okay, so this step is going to convert the Panda library back into NumPy array. So I'm going to do df3 dot ilog. Sorry, let me just back it out. So my Panda library has 3 columns. I want to separate things out into x and y. Recall into my slides that I have this one, right? That this guy right here. I have x and y. So I want to have x and y in my code. I guess that also makes more sense to if you want to have these consistencies. Okay. So my x is going to be consist of multiple columns, but y is going to be just one column. Okay. So the way I do that is I have to select 2 columns, the first 2, right? So I'm going to do ilog again, and I want all the rows. But then I only want the first 2, which is going to be 0. The way that I use is, okay, I use this one. So 0 and 1. So the first and the second column, if I were to do that, I get the first 2 columns. But you don't have to do this. You can also do df3.ilog. I can do all the row, but then I want the first 2 columns, which is 0 to 1. No, 0 to 2. Same thing, okay? So there are multiple ways you can do, but I suggest that you just pick one way and stick with that first before you kind of change things around. It's kind of confusing, but you can do either way, okay? So this one returns into you the data frame, right? But if you want the NumPy array version of it, then you do dot values. So I use this all the time in my code. Whenever I want to get the values out, if I were to do that, I get the value. See? This one back into like a more, I guess a more basic representation. This is the NumPy array, okay? And I'm going to save that into a variable called the big X, okay? So to be consistent with my notation in my slide, I use big X. So big X is the matrix consisting of 2 columns, like that, okay? I got X now. Next thing, I want my Y, okay? My Y is just 1 column, so I can do something like this, df3. If you want to select 1 column, first, you can do ilog, one column, all the row, but I just want the third column. That one gives you one column only. Okay? So this is a way to do, but this is not the only way. If you want to do something else, I can come up with another way. If you want to do one column, you can also do this target. Kind of almost the same thing, but actually behind the scene, it's not the same thing. The top one gives you data frame. The second one gives you what's called the series. Okay. But let me just try one thing real quick. I'm curious. I log that, and then I want to do 2. Does it work? I want to check this one out real quick. Yeah, it works. Okay. So multiple ways of selecting one column, 3 ways, which are, I guess, up to your liking. Okay. Okay, so again, this thing is still not NumPy array yet. This thing is either Panda data frame or Panda series. It's still Panda, a class instance. So I want to get the actual data out, so I can do dot values again. So you can dot value into all of the example. It will work the same way. So you can select one column, no matter what type it is, and just extract the values out. And in that way, see, I can get the NumPy array. So this one is like a more more rudimentary representation of your data. So I guess it's a little faster. It might matter if you have lots of data. Convert things into NumPy array first. Probably makes sense. But you do lose that indexing, right? You do lose that like target as a name, the header, and the row index and everything. So that's the trade-off. All right. So right now, I forgot one very important. I gotta keep this as my y. So I'm gonna do the lowercase y, and I guess I can do this for all of the things that I have up here. It's the same thing. Okay. If I do y equal, all of this works the same way. Okay. Okay, so far so good. Okay, now we got x and y. What's the next step? Let's go back to our slide. We are here. We're done loading the data. Wait, here. We're done loading the data. We already looked into histogram and scatter plots and everything. We prepared the data, so we got x and y done. So next thing, you're gonna split the data. Okay, let's do it. Okay, so in machine learning, if you have data, you're going to have to split it into, for now, I'm going to talk about only train and test. Okay, we're going to leave validation for much later on, probably after midterm. This one is a lot of confusion coming with validation data, so we'll keep it simple. But keep in mind that for the real publication, you should also include validation data. Okay, but for now, we're not going to use it. Okay, so as the name suggests, the train data is used for training, and the test data is used for testing. Okay, so that's a very simple explanation. But let's see what it is in detail. Okay, so the training data set is the model that's used to train the model. When we say the training, sometimes we use the word fitting. So we fit the model to the training data. Okay, and an easy way of visualizing, internalizing this is that if you let the model fit to the data, that means the model actually see the data, right? It reads in the data from your training data and actually learn from it. So learning meaning that it's trying to adjust its parameter so that it output the right answer. So that's called learning. Okay. Validation data set, I'll just briefly go through it, but we're not going to use it now. Okay, so this one is actually the data that model can see, because the model actually reads that data, but it doesn't learn from it. So that's the difference. It never learned from that validation. And the reason we do this is that we want to have something called unbiased. Okay? So unbiased is a term that's used in statistics. Have you ever heard of something called p-hacking? Or if you try to find the p-value of something and it's too good to be true, it's called bias. So that term comes from statistics. So we'll talk about this later. But the crux of it is that if you know the answer, you can always get good results. And if you do that, it's called bias. So when something is unbiased, it means you don't know the results beforehand. And when you're trying to evaluate your model, you want to have the unbiased evaluation. Because the unbiased evaluation should tell you how the model is going to perform in real life when you don't know the data beforehand. But if you only use the trained data, you are going to do a biased evaluation. That's the point. But we'll talk about it later after midterm. Okay. All right. So the test data. The test data is something that you can use to provide an unbiased evaluation. Okay. But again, if you don't have validation data set, this thing is actually not true. Okay, so that's the point. Like if you only have train and test, you cannot claim from your test data that your evaluation result is unbiased. So that's the point, right? And some of the referees, the reviewer in the publication do care about it. Some do not. So I guess if you're unlucky, you might get asked to redo your calculation with the validation set. So keep that in mind. You might get unlucky when you try to publish your paper. Okay, but for now, keep in mind that what we are doing is actually biased when we use test data. So it's not the real thing yet. Okay. All right. So in order to do the splitting, usually you allocate more data for training because you want model to be smart. So you do like maybe a 30-50, so 30-70. So the training data can be or 25 and 75. That's fine. If you have a lot of data, you might do 90 and 10. So only 10% of your data for testing and 90% for training. Okay, so depending on how much data you have. But the way that you actually split your data actually matter. So the first thing that you can do is just split your data randomly, and that's okay. But there's actually a better way of splitting your data. It's called stratified splitting. Okay, you're gonna come across this word a lot if you go into machine learning. So stratify. Okay, the stratified way of doing things. Okay, the way that stratified splitting works is that if you're going to split your data 25 and 75, so that means that you are doing 1 to 3 ratio, right? One part to the training and 3 part to the test. 1 part to the testing and 3 to the training. So 1 to 3 ratio. So if you were to do that within this training data, within this 75%, you want the same ratio of your. Sorry. Let me back out again. I did not do this explanation correctly. Hold on. Okay. The way that we do is that we are going to do no. Sorry. Hold on. Okay. So first, we are going to do splitting with 60 and 40. Sorry, I was wrong. Okay. We are so these are 100%. This is 100% of your data. Okay. And you are going to do 60%. This one is 60%. Okay. This one is 40%. Okay. So first, so 100 row, 60 rows in here, 40 rows in here. But then the stratified splitting is doing the work such that your class distribution is the same. So the way that you do is that let's say that in your data, you have the red class to be 25 rows. You have 25 sample of red class. You have 75 sample of blue class. So that means that your class distribution is 1 to 3. Sorry, I made a mistake explaining.
So the colors means
Class. Class. Sorry. Okay. So if you were to split this thing randomly, that means that in your training data set and your test data set might not have the same class distribution. right? You might have the training data set that has more blue, but you might have the test data set that has more red if you do it randomly, right? But the way that stratifying splitting doing is that it makes sure that your class distribution among the training and the testing data set is the same. So what it's doing is actually something like this. So in your training data set, you're going to have 15 samples that are in the red class and 45 samples that are in the blue class, right? So that means that this is 1 to 3 distribution of class. Okay, so in your 60 sample that you reserve for testing, you do have 1 to 3 ratio of class distribution. Okay? And also for the test data set, which is 40 rows, like given that we have 100 rows of data, you're going to have the 10 row that are from class red, and then the 30 row that's from the blue class. So that means that the class distribution is 1 to 3 again, right? So the stratifying splitting is so that the class distribution among the trained and the test data set is the same. Okay, sorry, I was confused about this figure previously. Okay, this might sound complicated if you have to write this in the code, or even if you have to do this in Excel. I think if you use RapidMiner, it should be pretty easy. Just do one tick, right? In Python, you can also do that too, because we already have the helper function to do just that. Okay, so let me go back to the code, and the way that we're doing is we're going to use this function called train test split. So this function is import from the scikit-learn model, and it do just the fact it was doing the thing that I was just telling you, the stratified splitting. Okay, so let's do that. I'm going to go back here, and I'm going to say that I'm going to split the data. So I'm going to do train test split. Right? We just import that function from the top. Okay, and this function required, for example, first it needs the x, so give it the x, right? Give it the y, okay, and then it needs the percentage of the test. Okay, so the test size equal. If you do 0.3, that means that you are reserving 30% of your data for testing. Okay, so 0.3 for the test data, and you want to do stratify equal y. Okay, so I'm intentionally omitting one option right now. I'm just telling you that if you want the stratified splitting, this is the thing that you need. So you want to do 30% for testing, 30% for testing, 70% for training, and stratified splitting. So let's do just that. Okay. So it's going to give you a lot of things. So let me just show you what it gives you, right? So result equal. You don't have to do this. I'm just showing you, okay? So let's see what it is, right? I'm going to go to my terminal, and I'm going to go to Jupyter and check out the results, right? The results is right here. It's actually a list. See? It's a list with 4 things in it, right? So and that 4 things is actually the array of your x with the train and test, and the array of y with train and test splitting. Okay. So if I were to do this, I will show. I can do something like this. Okay. I'm going to go back to my code, and I'm going to say result. The first thing 0, right? The first item in my list is the training data. The x that has the 70% amount of data. Like if you wanna check it real quick, I can do shape, because this is NumPy array. So this one has 70 rows. So that's 70%, right? If I do 1, so the second item in my list, this is x. This is x for the testing, right? If I were to do dot shape, because this is a NumPy array, I can always do shape. So give me 30. So 70 and 30. So that's the x that has split. Okay. If I were to do the third item, that's going to be my y. So that's my y with 70 items in it. Okay. And the last one, as you can guess, it's going to be my y with 30 items in it. Okay. So splitting 70 and 30 ratio. Okay. And I guess this one is kind of, if you have to extract things like this, it's kind of long. So we have a shorthand way of doing that, like this. We can do x train, x test, y train, y test. What this part is doing is that it's called the structure. Okay, so the return object from this function is a list with 4 things. I want to create a new variable, 4 new variable that gets the value equal to each item in the list that is returned. So that's that's a state, kind of the shorthand way of doing it. It's called destructuring. Okay, you can always just do this. Okay, just copy my code, and this is done, I guess, in everywhere. So you can just use this one called destructuring. Okay. Okay, so if you want to change the amount of your splitting, so feel free to change the test site. If you do 0.2, then you have the 80 and 20 splitting, right? I'm going to keep at 70 because I don't have much data, so I'm going to keep some for my testing too. Okay. So right now, if I were to do this X train, right? I want you to notice something. If I were to rerun this, right? And run it again. Notice that my data change every time I run this statement. See it again, run and run, right? My data start with 4.9 and 1.5, right? Let me just run it one more time. See this? It's actually change, like change every time, right? So this happened because it's actually, it's doing the stratified splitting, but then within that choice, it's still randomize your results, the selection, right? So if you only have this statement right here, every time you run the machine learning, you're going to get different results because your X actually changed because of the randomize in your selection. So if you want to make sure that your result come up the same way, and even for me, when I'm teaching you guys, I want you guys to have the same result as I do. I need to get some randomize to be fixed. So that's why the random state option comes in. Random state. Okay. So the random state is telling the system to kind of reset the randomize, reset the randomize generator, so that you always get the same random number in your algorithm. Okay, so if I were to set it to any number, just 1, right? Now notice that every time I run my code, I always get the same value out. And you can verify that with me. You're gonna get the same number as I do too. Like your stuff is going to start with 1.5. So you can verify that. If you type X train into your new cell, you should get the same order of the X as I do. And that's exactly because we specify the same random state. So something to keep in mind, because there are stochastic things that happen in the machine learning, like choosing the initial condition, and those kind of things can give you different results every time you run. But there's a way to fix things by choosing the random states like this. Okay? ตรงไหมครับถ้าไม่ตรงบอกด้วยลองพิมพ์ extend ผมหน่อยแล้วเช็คหน่อยที่ว่าคุณได้ sequence นี่แหละหรือเปล่าช่วยผมหน่อย Okay. So what I want you guys to do is can you go to maybe in this thing, just create new block and type X train for me, right? So that's you're gonna inspect this X train variable and verify that you actually have the same number, right? And that's exactly because of the random state specification. I mean, because if you have the same number as I do in this, that means we're gonna run the same mod. We're gonna build the exact same model that predicts the exact same thing, which is good when you want to share your result, right? You don't want people to run it and get different things. That's how we do. And just for something funny, something fun, like you're gonna see in some paper that they always use 42. You know why? Like in a lot of the code, people use 42. You know why? Yeah, from the movie, from the Hitchhiker Guide to the Galaxy. Yeah, it's a nerd joke. You don't know? Let me show you what 42 is. It's actually everywhere. You see, even in publication, they do 42, and I want to show you why. It's like, I don't know. It's kind of inside joke for the machine learning community. So 42. If I search 42 in Wikipedia, then we can do hitchhiker. Yeah, this one. It's a geek culture 42. Okay, so 42 is it's called the answer to everything. Like I guess in the movie, like if you I don't remember the story, but like the answer to the universe, like I think the protagonist was searching for the answer of something, and like he was trying to find it so hard, but then in the end, the answer is just 42, which is like so, I guess it's too simple, like it's too stupid. That's a joke in this story. And then I don't know why, but like everything machine learning, we always use 42, and now you know why. So if you want to like kind of spice up your code, you use 42, and people actually know that you know stuff, 42. Okay, but I'm gonna keep it as 1, shall we? Okay. Okay, so just to make sure that we actually have the right data, I'm going to show you this. I'm going to print xtrain dot shape, because in NumPy array, we can always do dot shape to check the size. I'm going to print xtest dot shape. I'm going to print ytrain dot shape, and I'm going to print ytest dot shape. Okay, and right here, you should be able to verify that our splitting works, because I have 70 rows of my X with 2 columns, right? We have 2 attributes, right? I have 30 rows for my test data for my X, which is good. And for my Y is just a vector, so it should not have any columns. It should have just 1 column, right? So it's 70 and 30. So this is good. Okay. Next step, okay? We are going to do feature scaling, okay? So back into our example, if I were to look at your box plot, you can see something, you can see this behavior. Notice that the actual number in my attributes, it's actually vary a bit. Actually, box plot is a better one, right? This one. You can see that my X actually vary a bit, right? Some of the X actually have larger range. This one has smaller range. This one has smaller absolute values. This one has higher absolute value, right? So the fact that you have this inconsistency in the range and the absolute value of your data is going to make the model think of each attribute as having different importance. So if you input this data into your machine learning algorithm, there's nothing wrong. I guess there's nothing to prevent you from doing that. You can certainly do that. But the algorithm is going to give more importance to this guy, because this guy has higher absolute value for absolutely no physical reason. So if you don't want machine learning to have bias in your data in terms of like importance, you got to standardize your data so that it has the same range and the same absolute value. So that's the process, to kind of equalize the importance, not to introduce the artifacts into your training model. Okay, so let's do that. There are multiple ways of doing it. I'm going to show you one way that I use a lot. It's called standardization. Okay, and it just sounds more complicated than it should. All it's doing is just to set the mean equal to 0. So scale your data so that the mean of your data is 0. So subtract by mean. And scale your data in such a way that the standard deviation is 1. That's it. So it's more complicated than it should, right? Okay, so you can certainly write the Python code to do this manually, but we do this all the time. So the scikit-learn library also gives you convenient tools to handle these steps. Okay, so let's do just that. So in here, if you go up, you're going to see that I already import this guy right here. It's called standard scalar. And take a note that this one is a little different because it starts with a capital letter. Whenever you see something that starts with capital letter, it means that this is the class blueprint. The class blueprint is something we talked about maybe a couple weeks ago. It's like my car. And then with the blueprint, you create the instance out of it. Okay, so whenever you see something with capital letter, you're going to have to create the instance out of it first. Okay, so let's do just that. So in order to do that, I'm going to just type the name of the blueprint. It's called standard scalar, like this. And do I need to specify anything else? No, that's it. Right? So this statement tells the program to create the class instance from this blueprint. That's it. That's it. Okay? But it's better to just keep it into another variable called sc. So the choice of this name is up to you, right? But we usually just use something that like this, short like this. And typically start with the lowercase letter. Okay? And again, this one is a class instance and it should have attributes and it should have methods to it. If you want to see what it does or what it can do, you can do dir and then sc. And these are the things that it can do. There's a lot of things. I can do scroll elements. Okay? There's a lot of things that it can do. Okay? The one that I want is I want it to fit to my data. Okay? But typically, this is not what I usually consult. Like, this thing is too detailed. I guess it's not detailed enough. I usually go to scikit-learn documentation, and I just search for it, like sklearn, standard scalar, like that, right? Just look into the documentation. It's actually better. I usually try to go to the stable version. This is the newest one, right? This is the class. As you can see, this is the class blueprint, right? And the method that I want actually goes down here, fit. See? Because this one tells me that if I were to do this, I gotta give it x, right? So I gotta give it x. So that one's pretty straightforward, right? Fit to the x data for me, please. Okay. So I'm gonna do this one. After this, we can take a break, shall we? Okay. sc.fit. Okay, and then I'm gonna use x. So see right here, you have a choice. Right now you have x train, and x test. Right, you have three things in here: x train, x test. Which one should you use? Okay, as you can see from my code, I'm using x train, and that is intentional. Okay, I don't use x. If you use x, you're biasing. If you use x test, that's completely wrong. I mean, it's not going to give you any error. But if you do x test, it's actually wrong because I'll tell you about it later. But the right way is x train. Okay? The reason behind this is that, let me just show you how it works first, and we'll come back into why I need to be quite specific in this. Okay? All right? So once you fit it, what happened? What happened is that it's going to learn what is the mu and the standard deviation of your data. So let me show you this, sc.mean with the underscore, okay? So this is the mean of my first x column, which is pedal width or length, I don't remember. This is the mean of my second column, which, I mean, if you go back into your box plot, it will make sense, right? If you go back here, box plot is right here. So this is about 2.8, right? Oh, sorry, this is the median. This is not the mean. So the mean is like here, okay? 2.8, and then 0 point something. Okay, so the box plot gives you the median, not the mean. Okay. Okay, and as you can sc dot var. Okay, so that is the variance of your data. So the standard deviation is the square root of the variance. Okay, but you don't have to care about this, right? In the end, you just want to transform your data. So this sc gives you a nice function called transform. Okay, I want to transform my data, so I'm going to do x train. Okay, like that. Okay, and this one right away it gives me the number that actually it also has negative number, and if you plot them, you're going to see that it kind of center around 0. Okay. Okay, so I'm going to keep this variable called x train underscore std, so standardized. Okay, so right now if you choose your variable name carefully, your code is going to make sense. For example, my x train is the unstandardized version, but when I do x train with underscore std, that's the standardized version. So choose your variable name carefully so that you don't make mistakes. Okay. I'm going to do another one, which is x test std, because I'm going to use it later on. Transform x test. Okay. Right here. Okay. See, so I want to show you the before and after transformation. And with that, let me just copy my code. This one, we don't use it in the actual machine learning, but this one just for this visualization purpose. So I'm going to concatenate the two array together, and then I'm going to rename it. So this one is just for visualization. You don't have to use it for in your real process. Okay, I'm going to do box plot. So this one just compare the before and after data for you. Okay. So this is the x1 before standardization, and this is x1 after standardization. You can see that it moved the value down so that the mean is 0, but again, the green line is the median. It's not the mean, so that's why it's a little bit off, right? Also, x2 goes into this x2 right here, right? And as you can see that if you don't do standardization, your model is going to prefer x1 because x1 has higher value and for no physical reason. But after you standardize your data, you're going to see that the model kind of gives the importance to each of your attribute equally because they have the same range and absolute value. So this one is actually very important. Like I've seen people make this mistake and the model goes just way off. Like this is just one line that actually saves you a lot of trouble. I can say that from my experience. Like when you forgot this part, your model just way off. It's just gonna predict something way off. Like I can guarantee that. So keep that in mind. This is something you should always do. Okay. All right. So let's take some 10 minutes break and we'll come back for the rest, shall we?